Greetings and welcome to another installment of Quantslob. This is 29 in our basic application series, and this time around, in response to overwhelming demand, we're kicking off our Summarizing Data Series. And when I say overwhelming, I mean like zero. Not a single person requested this series, which to a content creator such as myself is actually pretty overwhelming, but for better or for worse, here it is. Now, most of the content here on Quantslob is geared towards developing our data science and statistical skills, and this is certainly true of this series. However, nowadays pretty much everyone consumes statistics, data summaries, whether they be graphs or tables or just numeric. So even if our main focus is not on stats and data science, understanding how popular data summaries are created is going to empower us to be more fluent consumers of news. And who knows, it may also facilitate new academic and professional opportunities for us. But before we get too far underway, let's check in with our previous Quantslob challenge. This is from our Season 3 finale, Counting 4. So we have 6 available pizza toppings, and we have some collection of pizzas made from these 6 toppings, such that the proportion of pizzas containing any given topping is 1. And so the question or the challenge is, what does this collection of pizzas look like? Well, we can take a purely linguistic approach and simply convert what we know into a statement. For example, we have a collection of pizzas where each and every pizza contains all 6 toppings. Now, this collection might just contain 1 pizza or 2 pizzas or 10 pizzas, or I suppose it could even be some imaginary or abstract collection of an infinite number of pizzas. And this statement is quite sufficient for us to summarize the distribution of number of toppings on the pizzas within this collection. Now, we may most certainly calculate this distribution mathematically using our good friend, the binomial function. But just in case we don't already know this, 0 to the power of 0 is defined as 1. Okay, onward. Summarizing data. Okay, so where do we start? Well, how about what is summarizing data? And it may seem sort of silly, but I think it's worth mentioning at the outset that the term summarizing data means exactly what it says. It's a generic phrase. It happens to be a gerund phrase or a participle phrase, at least at the time of the making of this video. And that is to say, it is not colloquial, at least not that I know of, as opposed to an expression like breaking bread or breaking bad, for that matter. Okay, so I'm sure you've seen many examples of data summaries, but nonetheless, let's briefly explore a simple example. According to our data set, Major League Baseball from 2012 to 2019 inclusively, including spring training, exhibition, and postseason, pitchers have thrown a total of 6,452,250 pitches, and of these roughly 6.5 million pitches, 930,376 have been recorded as sliders. That's about 14.42% of pitches are recorded as sliders. And by the way, just so you know, some pitches were not recorded, pitch types were not recorded in our data set. Now, the original raw pitch-by-pitch data is rather large. In compressed form, these raw data take up about 3.1 gigabytes of disk space. In uncompressed readable format, these raw baseball data take up about 10 times that, about 32 gigabytes. And if these data were actually printed out, like on paper, the total printed area would at least fill about 1,000 large 3-ring binders, which would occupy about 30 bookshelves. Or if you're a fan of Russian literature, it would be equivalent to about 1,000 copies of Tolstoy's War and Peace. But the point here is that data itself is passive. It just basically sits there. A data scientist or a statistician proactively applies a process that transforms, perhaps, ultimately extracts insights from data. And nowadays, computer software does the heavy lifting. And of course, we all know what goes on inside of a computer. And I don't want to get a rep for body shaming hamsters, but I can't help but feel our little friend here is well served by a little bit of exercise. Now, I kind of like the distillation metaphor. We start with the sour mash of information, data, and distill out salient insights. Now, it often happens that the first part of our process involves taking raw data and manipulating or transforming it into a common data structure. namely a data frame. And this is certainly the case with our Major League Baseball data, as the raw data are made up of many thousands of individual isolated files. Our data frame can also be called stack data, or broadly, when on disk, a flat file, or even just simply a data rectangle. Now, each row represents our unit of observation, or if we like, an element. In the case of our Major League Baseball data, this is a so-called game event, which includes pitches. It also includes other things like pickoff attempts, player substitutions, and a few other things as well. Each column here, or field, in our data frame refers to an attribute, or if you prefer, variable. So let's step back and lay some groundwork here. So in a very broad sense, statistical research comes in two flavors: descriptive and inferential. Descriptive statistics treats our data set as our population, and our goal is to describe what is going on within our population. If, however, on the other hand, our data is a subset of a larger population, or we're assuming it is, then we may use our data summaries to make inference to patterns within the unobserved population. And there is a very important special case of inference that involves causality. Causal inference is usually accommodated by scientific experimentation. Now, in addition to understanding these two types of statistical investigations, description versus inference, stats and data science are often carried out in one of two investigative environments: exploratory and directed. Now, directed means that we have a specific question we'd like the data to answer. So, for example, someone may ask, what percentage of major league pitches are recorded as sliders, for example. Now, exploratory, as the word suggests, is a matter of prodding our data and seeing what sorts of patterns or insights we can uncover and summarize. Now, there's some good news here. Whether we are performing exploratory or directed investigation doesn't usually affect the process we use to calculate our summaries, so that's nice. However, how we actually calculate summary statistics can in fact depend on whether or not we are describing data, performing descriptive statistics, or whether our intentions are to make inference. And the reason for this difference, and it's vexing to some, is because when we perform inference, our ultimate objective is to calculate a summary or statistic from our sample, our data set, that can serve to estimate some property of our population. And it just so happens that sometimes the best way to do this, the most precise way, requires a small tweak in how we calculate our statistic. And additionally, it should be pointed out that the symbol we use to notate our statistic may be different as well. But this is not a problem, so don't even trip on this. By and large, in this series, our approach is going to be descriptive. But as we move forward, we're going to offer some commentary on the calculations. Okay, it should be mentioned that with statistical significance testing, our inference is performed in a directed investigative environment. Now, the lower right quadrant I'm showing here is where danger may lurk. Significance testing is not to be carried out in a purely exploratory environment. Doing so can lead to data dredging, which can lead to so-called hypothesis generation, resulting in p-hacking, which may ultimately contribute to the so-called reproducibility crisis. I just thought I'd mention it. Okay, now how we present our summaries is to a degree limited to our imagination, or in some cases, the imagination of the audience. However, we can break down typical summaries into three broad types: graph, table, numerical. One of the most important things really to keep in mind is that all statistical summaries imply some sort of comparison. And we're going to see that this is obvious with distributions, but most always lurking somewhere in the imagination of the consumer of data summaries is some sort of comparison, even when the summary is just a single numeric summary statistic. So with this in mind, now it is time for our Quantslob challenge. So question: when you heard that there were about 6.5 million total pitches in the 8 Major League Baseball seasons 2012 through 2019, what sort of comparison did you make in your imagination? Or what sort of comparison do you think someone might make in their imagination? We're going to pick this up in part 2. That's it. That's going to do it this time around. Thank you very much for tuning in. Don't forget to stay tuned for more Quantslob.